Hello guys, in today's video we are going to discuss the solution of the problem merge sort on doubly linked list. So let us look at the problem statement. The problem statement says that given pointer reference to the head of a doubly linked list of n nodes, the task is to sort the given doubly linked list using merge sort in both non-increasing and non-decreasing order. So let us try to understand the problem statement with the help of an example. So an unsorted doubly linked list is given to us and we need to sort this doubly linked list with the help of merge sort. And once we have sorted it, we need to return the sorted list. So that's for the problem statement, folks. Now let us discuss the solution of this problem. So over here, what we need to do is we need to sort a doubly linked list using merge sort. So let us see how we can sort a doubly linked list using merge sort. So let us say we would like to sort a doubly linked list using merge sort. So the first thing which we are going to do is we are going to check whether the linked list is an empty linked list or not. So if this is an empty linked list, then the head will be none. Or we are going to check whether the length of the linked list is just one or it contains just one node. In case it contains just one node, next of the head will be equals to none. If either of this condition is satisfied, then we are going to return head. Otherwise, so just like in merge sort, we are going to divide the linked list, the doubly linked list, into two halves, and we are going to use this split function in order to divide the linked list into two halves. And the head of the second half is something which will be returned by the split function, and we will see in a bit how we are going to implement the split function. But after splitting the array into two halves, then we have two linked list with us, which is head and second. So what we are going to do is we are going to perform merge sort on the first and second half of the linked list. And once we have performed merge sort on the first and the second half of the linked list, we are going to merge this linked list. And towards the end, we are going to return this merged list. So that's the algorithm, folks, in order to merge sort a doubly linked list. Let us just do a quick recap of it. So in the second step, what we are doing is we are seeing whether the linked list is an empty linked list or it contains just one node. In either case, we are going to return head of the linked list. Otherwise, we are going to split this linked list into two halves. The first half will be pointed by head and the second half will be pointed by second pointer. Then we are going to perform the merge sort operation recursively on head and second. And then towards the end, we are going to merge this first and second half and we are going to return the merged list. Now let us look into details how we have implemented split function and how we have implemented merge function. So let us first look at into split function. So again, in split function, what we are going to do is we are going to check whether the head is none or not. If head is none, then we are simply going to return head. Otherwise, we are going to split this head into two parts. So in order to split the head into two parts, we are going to rely on slow and fast pointers, and we are going to set it initially to head. Now we are going to iterate on fast pointer till fast is not none and next of fast is not none. And then over here the slow pointer will be increased just once. So slow pointer is equals to slow dot next, and the fast pointer we are going to increase it twice. So fast is equals to fast dot next dot next. And in this way, what will happen is the slow pointer will be at the middle. While the slow pointer is at the middle, the fast pointer will be towards the end of the linked list. And in this way, we will be able to find out the midpoint, and the midpoint is what? Something we want to return. So before returning the midpoint, we would also like to break the linked list. So what do I mean by this is, so let us say this is the linked list which we have, and let us say our slow pointer is over here and our fast pointer is here. Now before returning the slow pointer, we would like to break this connection. So let us break this connection. So remember, this is a doubly linked list, so the previous pointer is also available to us. So we are going to use that previous pointer. So in order to break the connection, we are going to say slow.previous. So slow.previous will bring us to this node, and then its next is something which we are going to break, and we are going to call it as none. And then towards the end, we are going to return slow. And in this way, we will be able to find the midpoint of the linked list, and we'll be able to break the linked list into two halves, and we will be able to return the second half or the starting pointer of the second half. So that's about the split function, folks. Now let us discuss the merge function. So in merge function, h1 and h2 is given to us. The first thing which we are going to check is if h1 equals to none. So this simply means this is a case where head 1 is none. So in that case, we just want to return head 2. There is no need to perform merge operation. Similarly, if h2 is none, then we are going to return h1. Otherwise, we will have a head pointer and we will have a last pointer. And the initial value of head and last pointer is none. And we are going to iterate on h1 and h2 while they are not none. So like in the merge function, we are going to check which is smaller. So if h1.data is less than h2.data, so if h1 is smaller, then the h1 data needs to be inserted into the sorted linked list. So the sorted linked list head is something which will be pointed by this head, and the sorted linked list last is something which will be pointed by last. So let us use that. But before inserting the node into the sorted linked list, the first thing which we would like to do is we would like to break that node from the linked list. So what do I mean by this is, if this is the linked list which we have, h1 data is somewhere over here. So let us say this is my h1, and this linked list is something which we are going to insert into the sorted linked list. So what we would like to do is we would like to break these connections, and this connection is something we would like to break. So let us break it. But before breaking the connection, what we want to do is we want to preserve the next pointer. So the next pointer is h1 dot next, and after preserving the next pointer, we would like to break the connections which we have. So h1 dot next equals to none, h1 dot previous is also equals to none. So these two connections we have broken, this connection we have broken, and this connection we have broken. Now let us break this connection, and that connection is essentially next dot previous equals to none. So in this way, we will be able to break the connections. And now we would like to insert h1 into the sorted linked list. So let us insert it. So let us say we have a function to do so. So insert head and last is the head pointer of the sorted linked list, last is the last pointer of the sorted linked list, and the node which we would like to insert, which is h1. So this will insert it. Similarly, if let us say h2 is smaller, then that will come into else case, and we will repeat the same process. So let us first preserve the next pointer. So next is equal to h2 dot next, and let us break the connections. So h2 dot next equals to h2 dot previous, and this is something, let us break it and let's make it none. Similarly, next dot previous is also equals to none. And once we have broken the connections, we would like to insert h2 on the sorted linked list. Head and last pointer of the sorted linked list, and h2 is the node which we would like to insert. And once we have done these things, so over here I have missed to update my h1 pointer. Now h1 will be equals to next. Similarly, over here also h2 will be equals to next. If there exist any nodes on h1 linked list, then all those nodes will be inserted on the sorted linked list. So the way we will be able to do it is last dot next is equals to h1, and h1 dot previous equals to last. And in this way, we will be able to insert all the remaining nodes into sorted linked list. Similarly, if there exist some nodes in h2 which has not been inserted, then we will insert it. So for that, last dot next equals to h2, and h2 dot previous equals to last. And then towards the end, we are going to return head. So that's the discussion of solution, folks. Now let us see how we have implemented this in Python. So the code is pretty much the same as what we have discussed. So this is the main function which we have, where we would like to sort the doubly linked list. So the first thing which we are checking is whether head or head.next equals to none. If it is a empty linked list, or it is a linked list which contains just one node, in which case we are returning head. Otherwise, we are performing merge sort, and the result of merge sort is the sorted list which we are returning over here. Now let us look at merge sort. So in merge sort, the first thing which we are doing is we are splitting the list into two halves. Now let us look at into split function. So just as we have discussed, we have a slow pointer and a fast pointer, and we are increasing slow pointer by 1 and fast pointer by 2 times. In this way, we will be able to find the midpoint of the linked list. Once we have found out the midpoint of the linked list, we would like to break that linked list into two parts. So this is how we are breaking it into the two parts, and then we are returning the head pointer of the second linked list, which is represented by slow. So we are returning that. So in this way, we are able to break the linked list into two halves, and the second half will be represented by second pointer. Once we have done that, we are iterating on, or we are recursively iterating on the remainder of the linked list, and we are breaking into two equal parts. Once we have done that, then those two equal parts are being merged using merge function, and then towards the end, we are returning merged. Now let us look at merge function. In the merge function, what we are doing is, if the first linked list is empty, then the answer is second linked list. If the second linked list is empty, then the answer is first linked list. Otherwise, we have a head and last pointer. Head corresponds to the head of the sorted linked list. Last corresponds to the last pointer of the sorted linked list. And then we are iterating while L1 and L2 both are not empty. If L1 is less than L2 data, then in that particular case, the first thing which we are doing is we are extracting the L1 node from the L1 linked list. So this is how we are extracting, or we are removing L1 node from the L1 linked list, and we are preserving the next of L1 linked list, since we have to iterate on the next pointer. Once we have done that, then we are inserting L1 node into the doubly linked list, and then L1 equals to next, since we want to proceed further. Similarly, and the same thing is something which we are doing for L2 linked list as well. If after this loop ends, if there still exists some elements in L1, then that element is something which we are appending into the sorted linked list. Similarly, if there exist certain elements in L2 which has not been inserted so far, then we are inserting that element into sorted linked list, and then towards the end we are returning the head of the sorted linked list. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.